I'm Scott Moore, and I'm a performance engineer. I help to make software and applications faster, better, more resilient. Lately, there's one thing on my mind.
Where's the best barbecue at, man?
So I'm going across the country, talking about performance engineering and barbecue. Join me as we take the performance tour.
Or are you performance engineer? Hold on. SRE, I got
All right, let's talk about the qualities and the differences between a performance tester, performance engineer, performance architect. And all of them are needed, right?
Yes.
The performance tester has to be very good at taking the performance requirements and making sure that the test results indicate it either does meet those requirements or does not. Make sure that the automation that's part of the performance test is accurate and matches what the business is actually doing.
Which means they need development skills, they need test management skills, they need test data management skills.
They need to make sure that the automation is right. Does it correlate the sessions correctly? Does it make sure that the data that's being used is accurate? The amount of data that's being used, the amount of data that's in the test system, looking at environments. Also, they need good analysis skills to be able to take that information that comes out of a performance test and let the truth rise to the top. Those are all really deep level skill sets. I mean, when you're looking at analysis, you got to know a little bit about web, a little bit about database. You got to be sort of knowledgeable in various areas.
A little bit about architecture because you have to set a monitoring plan for what you're doing under test.
So there's a lot in just a tester, but then when we talk about the engineer, now there's additional skill sets that are involved that are beyond testing. So what are the additional characteristics of it when you move it into the engineer side?
So when you move into the engineer side, you're starting to abstract this concept of time and resources away from a particular tool. So this is where you get skills that are portable from a testing tool over to a deep diagnostic tool or a monitoring tool, a catch point as an example, or you look at really deep diagnostic tools that appear inside of the Java virtual machine and .NET. You're able to take those skills, your analytical models, and say, okay, what is in use and how is that impacting my system performance? And you can likely answer questions related to system performance without even running a test, because you can get symptoms of issues coming from your monitoring tools and from your end user reporting tools. It says, hey, this is what the time is, this is the resources, and make recommendations. Very similar to a performance test, but just abstracted. And the architect takes that really to the next level, which is, hey, I'm looking at system documentation for how you're going to put the system together or how the system is constructed today, and I see patterns which are antithetical to good performance in this case.
And so all of those roles may actually be in use by the same person may be in that same role in various stages of the product development cycle. I guess.
Sure.
Right? So
You-
it may be the same person, but you're filling different roles. So it's not that performance engineering today is taking over performance testing. It's just that performance testing is a skill set in performance engineering, but there are other skill sets that are needed, and we need more of them today more than ever before because modern software is more complex than it's ever been, and there's more stuff going on. I mean, that we need to know. We need to have more skill sets than just I'm testing in this thing, this environment for this app, and this is the information you get. We've got to be able to branch out.
There are some authors that want to pit performance engineering against performance testing. Say one will replace the other, or one is more important than the other. The problem is performance testing is a part of performance engineering. We're still asking questions related to response time and the use of resources, but we're asking them in a very, very specific, narrowly scoped, multi-user reproduction of what's anticipated to go on in production. So we're using the test to generate our timing records, to generate our resource measurements, and then we're using our engineering analysis skills to analyze the test results. So one is not a replacement for the other, one is more a part or a subset of the other.
That's right. So there you go. It's not a matter of, ranking system. It's what is needed at the time. And those require some different skill sets. If you are now in the performance testing role and that's all you've been limited to at this point, and you want to gain additional skill sets to be a performance engineer, I mean, what are some of the things that they can do to just branch out?
Well, I'd say number one is communication. As you go from tester to engineer to architect, your ability to communicate at a business level and business level impact improves. Your architect should be able to converse about the impacts on the business itself. The engineer is likely going to be able to converse about the impacts on business operations from a specific piece of software. And the tester, of course, is going to be able to communicate about the risk associated with a particular app under a specific set of conditions. That's a big one. If you're not well versed at communicating to mixed audiences of different engineering levels from business to supremely technical, that is something that you need to work on. The other one is you've got to be able to decompose or separate the issue of timing records, response time, and resource measurements from the tool used to collect them or used to generate them, and be able to apply your analysis skills independent of those tools.
And that's exactly where I was going, was if you're stuck just being what I would call a tool jockey, if you're stuck within a tool, or you know the tool very well but you don't know the analysis side, you need to understand the analysis side. You can get into networking essentials, get into build your own server and start analyzing those things. If you're using Microsoft operating systems, get into Perfmon, Performance Monitor, get in on Linux systems, start looking at all those, what are those tools that we would use in Linux? It would be like RStat and VMstat, IOstat. Start understanding what those things are reporting back to you. That's studying those infrastructure, resources metrics. And then the next thing is, just get away from the tool for a second and start thinking about, I open up a browser, I open up DevTools. What is that showing me? What is that waterfall showing me? What are the W3C metrics all about within a Chrome browser, for example? When you begin to understand those things, you won't be relying on a tool to understand why you're seeing things that are taking longer than others. You'll be able to look at these other pieces and say, oh, I see this, you've got large images, or you're not taking advantage of cache planes, or I'm looking at the header information that's coming down, and I can tell from the headers what might be wrong. So
Help someone build an ultimate gaming machine as well.
Right.
If there's any class of individuals who understands performance at the hardware level and what it means to improve capacity and throughput, it's someone who's building a machine for gaming purposes.
stack developer who knows everything in IT and they can do it all?
Scott Moore.
No. I mean, there's a particular thing that they call those people.
Full stack developer that can do everything in a unicorn.
A unicorn. And you know what happens when unicorns work at your company?
You get to be a billionaire unicorn.
No, unicorns produce output. See this unicorn?
Oh, that's like the Squatty Potty where it makes the swirly ice cream, right?
Yeah, and that's what this produces. And when a unicorn just suddenly leaves your company, you know what happens?
What?
That's what happens. You're left with unicorn poop all over your organization.
Your unicorn just pooped on me.
That's right. So that's what happens to unicorns.